Alright, if you guys could please turn to the first page of your notes, Unit 1, Graphs. Hopefully you guys remember the distance formula and the midpoint formula. The distance formula can be used to find the distance between 2 points or the length of a segment. The midpoint formula can be used to find the midpoint. There are certain operations that you will need to be able to do on a calculator, and these are a few of them. Go ahead and just copy down the steps for now. We are actually going to do these things as a class at some point. But for now, just copy these down so that you have them in your notes. One helpful tool for graphing equations, especially if you're graphing equations by hand, involves symmetry, particularly symmetry with respect to the x-axis, y-axis, and origin. By the way, WRT is my abbreviation for with respect to. So anytime you see WRT, just think with respect to. So this is symmetry with respect to the x-axis. A graph is said to be symmetric with respect to the x-axis if, for every point xy on the graph, the point x negative y is also on the graph. For example, x equals negative y, every point xy, for every point xy, x negative y is also on the graph. A graph is said to be symmetric with respect to the y-axis if, for every point xy on the graph, the point negative xy is also on the graph. For example, y equals x squared. For every point xy, the point negative xy is also on the graph. A graph is said to be symmetric with respect to the origin if, for every point xy on the graph, the point negative x negative y is also on the graph. For example, forgot to write example here. Give me just a sec. There we go. For example, y equals x cubed. For every point xy, you have negative x negative y. Alright, I scrolled back up for just a sec because I decided I wanted to add something at the bottom here. To test for symmetry, basically to test the graph of an equation with respect to the x-axis, y-axis, or the origin, if you want to see if it's symmetrical with respect to the x-axis, you want to replace y with negative y, and then see if you get an equivalent equation. Okay? With respect to the y-axis, you replace x with negative x. With respect to the origin, you replace x and y with negative x and negative y. And if after you do that, you end up with something that's equivalent to what you originally had, you know it's symmetrical. If not, you know it's not symmetrical. I'm just going to really quickly talk about all the rest of this stuff. I'm kind of hoping that most of these things you guys remember from algebra and geometry. Slope is rise over run, and you can find slope using this equation. x2 and x1 cannot be the same thing, otherwise you end up with a 0 in the denominator. That would be an undefined slope. If you have a positive slope, your graph is going to go up from left to right. If your slope is negative, your graph is going to go down from left to right. If your slope is 0, you're going to have a horizontal line. And if your slope is undefined, that's when you have a 0 in the bottom. You're going to have a vertical line. Okay? There are three forms, sorry about that. There are three forms of the equation, of a linear equation. There's the general form, point-slope form, and slope-intercept form. This is the one I tend to use most often, but it's good to know these also. M represents the slope, B represents the y-intercept. If you're going to use general form, A, B, and C are all real numbers, and A and B cannot both be 0. Okay? Alright, for parallel lines and perpendicular lines, in algebra, you learned that parallel lines had equal slopes and different y-intercepts. In geometry, you learned that parallel lines are coplanar lines, that means lines in the same plane, that never intersect. For perpendicular lines, in algebra, you learned that perpendicular lines had opposite reciprocal slopes. And then in geometry, you learned that perpendicular lines are lines that intersect to form a right angle. Okay, circles. Circles look like this. The standard equation of a circle is this here. HK is the center, and r is the radius. The radius is the distance from the center to the edge of the circle. It would be a good idea for you guys to memorize these graphs. These are some very common graphs. You will be allowed to use this page as a reference during quizzes and tests, but it would be a good idea for you to have just a basic idea of what each graph looks like in your mind, so that when it comes up in any kind of problem, you know what, you are able to make the connection between the equation and the graph. So I'm scrolling up and down. These are the first 6, and these are the last 6. Feel free to pause and rewind as needed, and make sure you have them all copied down. And that's all for Unit 1.